So shall we wait or we should start?
Rocky sir, Rocky sir. Right.
Yeah.
Yeah, Sony ma'am, you have to take a decision on this because I have no problem to start immediately. I was just typing actually on the chat that everyone online, please scan the yesterday's notebook once so that they are recalling what they learned because morning would have been a different session, so now they would have forgotten what we learned yesterday evening.
Yeah.
Maybe you can start your introduction and then we will immediately post that start.
Okay.
Okay. Okay, fine. So we'll
Yeah.
start. Yeah. Uh, Good evening, one and all present here in this online meet. I, Professor Soni Bhambar, on behalf of the organizing committee, welcome you once again in the evening session of day 4 of AICT sponsored 2-week second FDP on insights into intelligent automation, machine learning, and data science for the theme artificial intelligence and machine learning. Once again, we have with us the most on-demand speaker, Mr. Rocky Jagtiani. I welcome you, sir. And I also request you to take over and start the session.
Sure. Thank you, Sony. Right. So, friends, very good evening to all, and we'll be beginning with our session. So, first, a humble request that we had at this notebook yesterday of decision trees. So, please open up that notebook so that you're all ready with it. Right. I have just shared my screen. Is the screen visible? Please punch in me a yes if it's clearly visible. Please say a yes on the chat. Okay. Yep. Thanks, Indrajit. Okay. Now, let us first, before we start and jump into coding and into more concept building, let us first have an entire path set of what we are going to be doing today. Today we'll be finishing with this notebook called Decision Tree for Regression. So decision tree is not only used for classifying objects, it is also used for regression based problems where it can predict the next best value for you. Now, after we finish with this, which should take us, let's plan that out, which should take us not more than 25 minutes to finish with this. So before 5:30, we ideally should have finished with this much part of the working, okay, according to your notebook. And so let's assume that we finish this in the next 20-25 minutes maximum. Then we are going to go to our next notebook, which is random forest algorithm, where we are going to understand of how this is better than decision tree. It is based on decision tree. The reason of learning decision tree actually was to teach you random forest. So random forest, because the word forest means collection of trees. So here it's collection of decision trees. So we're going to learn this technique and any technique, or you can get this simple word in machine learning very clear, that any algorithm in machine learning, which is a collection of two or more algorithms, maybe two or more same type algorithms or two or more different type of algorithms, is called as ensemble learning. It's not machine learning, it's ensemble learning. So ensemble learning, random forest is example of ensemble learning. So we'll be doing with that. There are other ensemble learning techniques also, like XGBoost is one of the another good example. And we are going to pick up the same data set which we took in the yesterday's case of decision tree problems. We are going to take the same data set here and see how better is this going to be. There are two questions over here of what bagging means and what is out of bag error. I will explain to you, but I've also put the video for your ready reference. Okay. Then once we get into this, you will be realizing that again random forest can also be used for solving regression problems, and random forest can also be used for solving classification problems. Okay. Now, when we actually solve this, a very big question is going to come to your mind. And that very big question that comes to our mind and sits in our mind is, in the random forest, some trainer like Mr. Rocky Jagtiani said that it's a collection of trees. And in the random forest, the parameter number of estimators means number of trees. Usually we choose anything like 10 to 50 or maybe 100 or 200, something like this. So anything from 100, anything from 10 to 200 or 300 is the values, usual values of number of trees which we select inside a random forest. Question is, which value should I choose? What would be the best value of the number of estimators? It's not really important that more the number of trees in the forest, the better the performance. No, not at all. That is not the case. So the point is that uh, so when we come into this notebook after half an hour, I'm going to share this notebook with all of you at 5:30, not now, at 5:30. That time we will be also answering this question from 5:30 onwards, that how do I get the best value of the estimators? So we are going to actually simulate by writing some simple Python coding of how we can find and plot that if I were wish to plotting the mean error, have a look at this simple chart. Don't understand anything. I'm just saying, don't understand from the algo point of view. Just understand the chart. That if I have this chart in front of you, in which the y-axis is a mean error and the x-axis is number of estimators, you'll be surprised and happy to know that simply increasing the number of trees in the random forest does not give low errors. Please see. In fact, if I choose the number of trees in my tree in my random forest is 60, from 60 onwards up till 200, I'm getting a high mean error. Remember, error is a negative reward metric. We did it day before yesterday. Mean error is a negative metric. Jitna kam utna better. Jitna less hai utna better hai. So this mean error, please notice, is quite high for in fact large number of trees. So the best values would have been if you kept the decision number of decision trees to either 20 or 30 or 40 or 50, or for any value between 20 and 50, maybe 25, maybe 37. That would have been good. So we will be doing this kind of an example, and this example teaches us something called as hyper parameter optimization. Please remember our very first day of machine learning, we did some diagram, right? ML pipeline, in which there was a small circle, small box, small block diagram, which said, if you recall, it was collection of data, then data preparation, then you made an ML model, then you evaluated the ML model, and if the ML model was not satisfactory, you went in for the last block called hyperparameter optimization. And then I did mention to you that this is a recursive circle. From model evaluation, let's say ME, model evaluation, you will go to hyperparameter optimization, again back to model evaluation. If you're happy, exit, deploy your model. If not, again go back to hyperparameter optimization, and this is a viscous circle. You go on and on and on and on, right? So one small example was important for all of us to know how to do hyperparameter optimization is through the random forest which I'm taking. Although hyperparameter optimization can be done for every algo we do, but that is going to consume time. Then that particular case, it would happen so that we end up only doing 2 algorithms instead of 4 or 5 algorithms. Okay, right. So let's first finish what is pending, friends. Decision tree for regression. So you're all set. Come on, punch me a yes. Everybody set on the notebook. Everybody is geared up. Sabne sham ki chai pe li, and you're all set in front of your computers. Say me yes on the chat. Type a yes. Yes. Now that's my friends. You all have punched in a yes. Very good. So let's move further. So friends, we are going to take the same example of the 48 US states data which we already have. In this data, we have to predict the gas consumption. There is an objective. The reason of I'm taking the same data set across algorithms is so that you know that when I have the same set of data and I change my algorithms, do I get better or worse accuracy? So you are able to compare. It's that the notebook is changing, data is remaining same, the algos are changing. Okay, so you have a connectivity. Once you start over, well, let's say when you have to refer back your notes, you open all your notebooks, you have a complete connectivity in front of you. Okay, right. So let's see. So we are using petrol consumption.csv dataset. We want to predict gas consumptions. And there are 48 US states. That means there are 48 rows, 48 samples. There are 4 columns, 4 input features given to you. How much tax the government is charging? What is the per capita income? What is the length of the highways in the given state? And what is the proportion of population with driver's license? So friends, I need not ask you to download the data from the Google Drive because you already have the data on your terminal. But if you don't, I have still given the Google Drive link here. So come on friends, quickly upload this US petrol consumption data on your Colab notebook. Come on. And once data is uploaded, say uploaded yes. Okay. So majority people have said uploaded yes for this answer of uploaded. Very good. Okay, so what I'm doing next is I'm doing pandas or read CSV just to read the file and do a head to check my data. So I can see my data the way it was yesterday. I've got my 4 columns: petrol tax, average income, paved highways, population, driver license, and the 5th column as petrol consumption. We know beforehand that the first 4 columns are X input features and the 5th column is Y, which is the output target variable. You will be noticing that from the last 4 days, we have been doing, it was the 4th day of course, have been doing data set in which X is also given and Y is also given. Yeah, because the reason is that there are lots many supervised machine learning algorithms as compared to unsupervised machine learning. So unsupervised machine learning doesn't have much choice. It has 2 or 3 algorithms. Out of that, one of the popular algorithms for clustering we'll be doing in hands-on in the class. Okay, now let's have a look further. So what I'm doing now is I am finding from my data frame the target variable petrol consumption's mean value, and it comes to 576. Can anybody help me to answer this? Why am I finding the mean of the target variable? With what will I compare this? इसको मैं किससे compare करूंगा? With what will I compare this? Please, on your chat, answer on your chat. Correct. This Smita is absolutely correct and super fast. It is going to be compared with RMSE, that is root mean squared error. Very good. We are finding the mean of the target variable because we will be comparing this with RMSE. Please recall, friends, whatever RMSE value you and I get, we have to ensure that this RMSE value, or not ensure, rather we'll compare, we'll check whether this RMSE value is less than equal to 10% of the mean of the target variable. So symbolically, I could write it like this: that is RMSE less than equal to the mean of the target variable. This is the usual way we actually put it down. Okay. If you look at the research papers, my goodness, research papers have too many conventions. But if you look at the practical world, if you look at we developers are a little away from the research papers, to be very honest, because we developers believe more in the fact that can it be implemented, and research papers believe more in mathematical models. They're not worried about the implementation aspect of it. And that's the reason I'm sure all of you people, out of which some of you are already doctorates. So yeah, I believe that you're more senior to me in terms of experience, in terms of knowledge. So you will agree definitely with me that many research papers are non-implementables. They're not implementable. If you give a research paper to the best developer also, he says he implement nahi ho sakta. Okay, mathematically yes, but coding no. Okay, now let's move further, friends. What we're going to do next is I'm preparing my data. I'm dropping the petrol consumption column to get the X. That means out of 5, 4 features will come into X. Only one column, petrol consumption target variable, will go into Y. Next, I'm importing train test split and I am splitting this. data, and that's what I've got here. So I've got X train, X test, Y train, Y test. Next, what am I doing is I'm importing decision tree regressor, and by importing decision tree regressor, I'm making an object of it. I'm training my system on it, and then obviously you're going to ask the regressor to predict the value for X test to get the Y prediction. And once this is done, as always a habit, we are going to form a data frame so that we can see what is the actual value of Y test which I and you have. This is what we have, and this is what was being predicted by the system. We're printing the data frame. So that's what I get as an output. Now, whether you have to get this output or not depends whether you have the code or not. So come on, find out and tell me. क्या आपके पास सारा code है? Do you have the entire code or something is missing? If something is missing, give me an indication what is missing. Yep, I'm still waiting for people to answer. Line 4 in earlier, line 4 in earlier. Okay, line 4 in earlier, so that is the okay, okay. I'm sure you can do it yourself. I don't need to punch this. I shouldn't punch this now. After in the mid of the second workshop, if we have to punch one line codes, then so I don't think so. We are really going at a very. I don't think so we're deriving what the workshop should be used for. So, so data set petrol consumption mean is. You've got this answer here. That's good.
Sir, yesterday what we have done, the same book, na sir?
Yes, same book. It's called decision. It will be named as decision card trees. That's right. It is the same book. You're correct. Decision card trees. Yeah, Indrajit, you said you have typed the code, but some people who are not able to type the code may feel confusing. Okay, so I think Vishali has given me the specific answer. Training and making prediction is not there. Okay, training and making prediction is not there. That means from sklearn tree import decision regressor. This is a part of the first comment. This is not there, and then the part of prediction. This is a part of prediction. This is also not there, so that comes your way. Yeah, so as Bhuma Devi, I hope you got the point where we are. Can I help you more on this? Are you
Sir,
got the
file error it is showing. I don't know.
oh, hold on. You're showing file error where you when you are uploading the data?
After uploading is done, but in the when we are reading the data, that time I'm not getting that particular part.
Okay. Okay, so that means I'll just scroll for you. Okay, just check one thing, huh? When you say period.read CSV, please ensure that whatever file name you have given here, petrol consumption.csv, and what you have uploaded, is that name matching? Just check.
Petrol underscore consumption dot csv.
Hmm. If this name is matching, it will definitely read. Why it will not? There's no problems.
Because by mistake, na sir, the beginning part, first part of the program I have run. I have not straight away. I had come to this level.
That is okay. That is okay. You may run the upper part, but the upper part is using a different data set and is using a different algo. And this is using a different algorithm. So I'm again re-importing everything. So I don't see any reason why this data should not get uploaded. Can anybody on the group help?
सर पेट्रोल कंजप्शन नहीं है सर, नहीं नहीं, ये दूसरा है.
हाँ
सॉरी
तो
सर, मैं
वही
देखती हूँ अभी.
ठीक. Okay, Sakina has a point and she's saying preparing data is missing. Sakina, are you trying to say that splitting the data for into X and Y is missing? Okay.
Now I got it, sir.
Very nice.
Okay, sir.
Yeah. So now you bug up fast, huh? You have to bug up fast with the so that you can match with the class. Okay. Now I believe all of you have complete code, huh? X and Y I have punched on the group preparing data. Train test split, it seems you already have it. Please check that the code which you are using also has a random state 0 and test size of 0.2. My notebook could differ from your notebook. Please understand. So for us to match our answers, please ensure test size 0.2, random state 0.
So, this is
Yes.
Atiksha. Can you
Yeah.
just go scroll above because the earlier code, that one line code is giving me error. I'll just check whether I have
Yes.
typed it properly
Yes.
or not.
The only error that can happen here is the petrol underscore consumption spelling may have gone wrong. That is the only problem.
Yes, I'll just check it.
Yes, yes. I'll still punch that code Apeksha on the group also for double verification.
So actually, everything is correct.
Mhm.
In my case, in the spelling, the P and the C are small because I have checked my file. The P and C are small, but I'm
No,
getting the error as key error.
no, key error means that only. It may not be because I can see my file here. Na? Petrol underscore consumption is capital. I can see it here. I always copy. I never type. I always copy the column name and put it there. So it is capital. P is capital. C is capital. 100%.
Sir, ये sorry for the disturbance, sir. ये from
Mhm.
sklearn tree import this वो वाला किधर टाइप करना है क्या सर? किधर पंच करना है?
एक सेकेंड एक सेकेंड आप मुझे पूछ रहे हैं कि फ्रॉम एस्केलर्न इंपोर्ट डिसीजन ट्री रिग्रेसर ठीक है
Yes, sir.
फर्स्ट ऑफ ऑल विद पेशेंस डोंट जंप ऑन दैट come to this particular cell. Do you see the cell on my screen very clearly?
Yes, sir.
Right. So please notice very carefully. First comes clearing the data and dividing the data into attributes and labels. So I have also punched this separate where you have X and Y. Have you first, Bhuma Devi, first answer this question. Have you done the work coding of X and Y?
Now only I'm doing, sir.
Then you will get X and Y coding on the this thing. You will get the code for X and Y on the chat. If you carefully notice, you will see the code
Yes,
for
sir.
X and Y both.
Yes, I got it, sir.
Only
Then
X and Y. Huh?
sklearn model import train and test that we have to run, na, sir. After that,
Yeah, after that there will be sklearn.model selection. This code is already there with you.
yes.
Correct. Then the code comes which you were asking for from sklearn.tree import decision tree classifier. This code also I have punched on the group. So see on the screen carefully and slowly, gradually see where the code has to get fit.
Yes.
Hmm. Vismita, I just saw your error right now. You say that data set uh, petrol consumption dot mean. Let me just pick this up and put it here. Vismita, you left a space in between. Please check. Should not be any space. It should be attached to this, as you can see very clearly here. So I'm Repunching that back to you. Ms. Smita, over to you. Friends, 1 more minute and the deadline gets over. 1 more minute to check your code on the screen and the deadline gets over.
Sir, 1 minute. The SK decision tree, that is the last step that you taught.
No, I have thought everything, and the code is also, output is also come here. I have thought that 10 minutes is over. Bhuma Devi, please understand. Uh-huh.
Why, Pradeep?
Therefore, Rathore sir always reminds on the group that please come 2 minutes early. Join at 4:58, 4:57. So that all these warm-up things can be done that time only, no? Okay. So now how many people have finally got their answers? Come on, please put me a yes. Okay. So I believe lots of people have got their answers, and the code is visibly on the screen, and the same code was also punched to you. So I don't think so there should be any more confusion. Now we have got some answer, but the point is that how good or bad our answer is, we don't know. So immediate next cell, please notice the immediate next cell, I think should already have the code from sklearn import metrics. I think this code should be there with you. Is it or not? It's there. Okay. Right. So I'm only bothered about my root mean squared error, and my root mean squared error is 77.75, and I'm not happy with it. I'm not at all happy with it. Why? Because my friends, your value of RMSE in this case is coming as 77.75. Oh my goodness. This is no way less than 57.6, which is 10% of the target variable. Oh yeah, this is not at all less than this. That's right. It's not even close. If you would have got assuming 57.75, I could have still tolerated. हाँ चलेगा system चलो use करते हैं. But the system is terribly bad. So I don't think so I will be ever using decision tree regressor over this data set which has been given to me. I don't think so I will ever use this. So when you get such worse results, no, इतना जब खराब results आपको मिलता है ना, don't even think of hyperparameter optimization. See, when in generic sense, when should you think of hyperparameter optimization? Assume that your answer was not 77.75 or Sakina got 68.46. If your answer is not that way, or let's say your answer was 56.89. I understand it is less than 57.6, but the more the lesser it is a better. No, it is more merrier. So in this situation, you are actually on the borderline. Please understand, you are on the borderline of a threshold. In this situation, I think you should try hyperparameter optimization once. Maybe this reduces to 52 or 50, and that's good sign for you. But if you are so far away from the target variable, it doesn't make sense. It's stupidity. But there is no sense of you trying this, right? Any hyperparameter optimization you do is going to be a waste of your energy and time. So I hope we are very clear now with what we have done. Okay, right. So friends, you've done a fantastic work. See, notice the time, it's 5:30 and we are on target. And we are going to now move on to the next notebook. Let me share the next notebook with you. Random forest, yeah, that's right. Okay. Now, the next notebook has been shared, and the admin of the session today was Sony ma'am. So Sony ma'am will also pick up this link and put it somewhere on the Moodle so that people who are absent or maybe latecomers can download it from the Moodle.
Yes, sir, sure.
Yep, thank you. you would find in my notebooks something like a prerequisite, and that prerequisites for all covered in the FDP1. So, people attending FDP1, FDP2, and FDP3 sincerely, trust me, they are going to be kind of, yes, I understand that the information which is coming to you is in scattered form. You may not find it in a continuity, maybe lagging because of the fact that trainers are changing. So you may not have 100% connectivity. It will look like a broken linked list. But trust me, if even if that broken linked list is given to you, it's like a zigzag puzzle. If once you start putting them into proper places, you will see that, oh, the big picture is very beautiful. Okay, so how many people are ready? They have opened this notebook and it is completely opened in their browser. How many people are ready with the random forest notebook? Okay, so many people are ready. I think we should start with this particular notebook now. Now, let's understand this funda. So friends, what happens is, in the case of a decision tree, let me first bring out the major and a big disadvantage of decision tree. Therefore, we use random forest actually. So decision tree has a tendency to keep on growing. It just keeps on growing. I did mention yesterday that we can restrict this particular parameter called max underscore depth of the decision tree. We can restrict it, I'm saying, but by default is not restricted. By default, the default value of max underscore depth is none. If you print the object of decision tree, you will see max depth is none, which means that there is no restriction on the growth of this kind of a tree. So this tree can actually grow and grow and grow and have lots of leaf nodes. And because this tree keeps on growing, it becomes very tall and very wide. You know, every node there is a bifurcation. So it's going to become wider and wider, and because there is no restriction only on the length, so the height becomes very huge. Now, in this situation, when the tree height becomes very huge, we see two problems happening. First problem, which I'm sure is very evident. Even if I don't speak, you know it. Because the decision tree is too large, it will take a considerable amount of time to predict the output, whether to classify values or to predict the output. So in short, it will take time to give an output. That is the first problem. It takes little more time compared to other algos. Little more time. If other algos take 1 second, this guy will take 1.5 seconds. That is one problem. Of course, that can be easily covered up by restricting the maximum depth. So that problem is solvable. First problem is solvable. Second problem is not solvable. What is the second problem? Second problem is, because the decision tree is allowed to really expand, to its heart. जितना उसको चाहिए वो अपने दिल से, मतलब जो मर्जी है जितना expand करना चाहता है वो करे. So it is, you are allowing him to expand. The decision tree practically takes every feature into the picture. So every feature right from F1 to Fn has been considered to take some other decision in the nodes. Actually, that should not be the way. You should never consume all the features in the feature set to take decisions. That's not a good practice. So you can imagine if there is a data set which is having a few thousands of features, like this tree is going to be maddening big. Now this tree is going to be maddening big. Then obviously you would notice that this tree is unfortunately noticed most of the times to be overfitting to the data. Now I want some people who asked me yesterday, 2-3 people asked me on the chat as well as verbally that I would like to know more about the covariance. So try to get these things clear, because these all things are internally interrelated. So a decision tree, if you let it expand completely, it ends up overfitting to your data. Now, what could be an example of an overfitting? If you have seen the videos of linear regression and ridge regression and lasso, I'm sure you would have noticed that the video says that if these were your points, and if you form a complex mathematical model, and this complex mathematical model goes like this. That means the complex mathematical model says that I am going to go The complex mathematical model says that I am going to go and traverse every point. If you traverse every point, my friend, you have made a mathematical model with obviously zero error on the training set. Zero error, no, exact zero. There is no error only. The training set, it is perfectly fitting the training. It is perfectly fitting the training is good. But moment I have some test points, and I try to test on the test points, I find that the error is very high. And the error is high, which means variance is high. Error is high means variance is high. So the point is that this model gives you very high variance. Okay, how does it help? So very high variance basically means that whatever predictions you're doing are very away from the delta. The difference between the prediction which you have done and the actual value is very large. The delta, the difference is very large. Oh, interesting. So if my model is perfect, then it is overfitting, correct? If it is overfitting, it will definitely have high variance, correct? If it is having high variance, that means what the model is predicting and what the actual value is are very far apart, correct? Therefore, such a model is effectively useless. That is also correct. Such a model is useless because it is overfitting to my data. And when any model overfits to the data, means what it also means in very generic senses, it is not generalizing. Please remember the very first day session, we had this term called generalization. I told you I'll talk about it at the right time. If I would have spoken that time of all about this, it would have been kind of overdose. So because now even if you've started machine learning with me and with the FDP2 program, I'm sure you're able to connect whatever I'm trying to say. So overfitting model will never generalize. It will never have a generic behavior. Now what does generalization mean? Generalization means that if I give you a model built on some training data set, it should give fairly good accuracy on all different test cases. Today I'm giving you test data set 1, tomorrow I'm going to test data set 2, then I'm going to test data set 3. So every day on day when I'm giving you new data, your model should give me the accuracy within a confidence interval. Let's say your model is giving me an accuracy in the confidence interval of 88 to 95. That means your model in every case will give me a minimum accuracy of 88% and a maximum accuracy of 95%. So your model should give me its accuracy value within a CI, within a confidence interval. And this confidence intervals are calculated by taking 95% of truth in the hypothesis, means by taking 95% of the data set, we are calculating this confidence intervals. Okay, you can just forget about this. So in short, it should give you this kind of a range of data. Okay, right? So I hope this is going simple and clear. I summarize my points. I'm summarizing the points. First point, decision tree overfits. Because decision tree overfits, therefore it gives poor results. Poor results when? Poor results on the test data. Huh? Very good results on training data, but poor results on the test data. It is as good as saying that you were giving an exam, but when you're giving the exam in your own college, you're doing very good. In your own home, you're doing very good. But moment the exam comes on, that you're going to some other college and giving the exam, you're performing bad. What has gone wrong? Something has gone wrong, right? So some player is performing very well in the country, but moment he goes internationally, not performing that well. So it means he's giving poor results. On the actual ground is giving poor results. So what is the solution? Solution is very simple. Solution is that we should go ahead and make a collection of trees called random forest. And the big question is, if I use a random forest, then how do I predict? Simple. Random forest, first of all, is a collection of decision trees. It's not one single decision tree. It's a collection of decision trees. Now, friends, if you are having a collection of decision trees and there are n number of trees which you actually put, maybe 100, maybe 50, like this. Now, each decision tree uses a subset of the data doesn't use the entire data. No. It is a subset of the data. So if you have a total data set, let's say S, capital S, your total data set is capital S, then at every point of time, a small random set of data is taken, assuming let's say 20%. So at every point of time, I'll take 20% of the total data set, and that's called as a bootstrap data set. It's called BS, bootstrap data set. So I will pick up at random 20% records from my entire sample space or entire set data, and I will give it to this fellow called decision tree DT1. DT1 will take this 20% bootstrap data, let me call it as BS1, and will start forming this decision tree. So it starts forming this tree. It first picks up that feature or that column on which the data can be broadly divided into two categories. Example, let's say gender. So I can pick up the gender column and divide my entire data into some males and some females, right? So some data comes here, may not be 50-50%. I'm not saying decision tree should do 50-50%. No, not important. It could be 80% here and 20% here. That's okay. But funda is, give me that feature on basis of which I can neatly divide my data. Simple. So I'll pick up that feature on which data can be quickly, neatly divided into. That becomes my root node feature. Then again, I pick up some other feature here, let's say F3, and further divide my data. And like this, the tree goes on growing and growing and divides the data into small, small pieces. Okay. Every tree will have its own bootstrap data set, obviously. So if this is the 100th, if this is the 100th decision tree, DT100, then this will have a 100th bootstrap data set. Perfect. Absolutely. Now, if you are taking at random data from, listen to me very carefully and please answer the question. I'm going to have an impromptu question here. From this entire data set, let's say of 1000 records total, you're picking up 20%, that is 200. And you're going to make such 200 bootstrapped data sets, isn't it or not? Sorry, you're going to make such, not 200, I'm sorry. You're going to make such 100 bootstrapped data sets because you have 100 decision trees. So my question now is, do you agree that in each and every bootstrap data set, there is a possibility and a high likelihood of repetition of records? Yes or no? Okay, so I'm getting an answer from yes from many people. That's right. So when you do a random selection of the records, repetition is likely, and that's going to happen. First point. Second, is it really important that all the 1000 records which I have, I repeat, all the 1000 records which I have in my total set, all of them will be consumed in some other bootstrap data set? Is it possibility that maybe 1 or 2% or 3 or 5% records from my total set are left out? They never got a chance to come in any of the bootstrap data set? Give me an answer, yes or no. Is there a chance, yes or no? Yes, possible. Absolutely, Dr. Kranti. Very good. So it's quite likely possible that some records may be left out. Usually this is not 3 to 5%, it is close to 30%. On large data sets, close to 30% records never ever make to the bootstrap data set. So these records are called as out of bag. They are called as out of bag. Why out of bag? Because they never got a chance to go into the bag. The bag is a bootstrap here. Okay, so the bootstrap set is the bag. So they never got a chance to go into the bag. Therefore, they're called as out of bag. Okay, right? So obviously, these records, when they never get a chance to go into any of the bootstrap data set, it's very natural that there needs to be calculation of an error factor that, okay, how many records could not go, and if somebody says that out of okay, out of 1000 records, okay, 30 records never got a chance to go in any of the bootstrap set, right from the first bootstrap set to the 100th bootstrap set. I didn't get chance to put these 30 records in any of them. Okay, so that means 30 upon 1000 is 3 upon 100. and that is a neat 3% out of bag error. This is called as 3%, which is the out of bag error. Why error? Because these guys never got a chance to go in any of the bootstrap dataset. Okay, so I hope that the basic fundamental way of how many decision trees in the random forest get the data is clear. Now, the next point. Now what I'm going to speak is very simple. Random forest again has two classes: random forest regressor and random forest classifier. The random forest regressor, the random forest regressor says that every decision tree will predict its output, because there are so many different decision trees, no? So all the decision trees are going to predict their output. So let's say the first decision tree predicts some output P1. The 100th decision tree predicts some output P100. Question mark. Which value should I report to the user? It's very simple. You will take an average. Mu means mean, mean means average. You will take an average of all the values. Simple as that. Where the value of I is ranging from 1 to 100. As simple as that. You get your answer. For random forest regressor, random forest classifier is a very democratic person. He works way any democratic country is going to work. So if you are having once again 100, so 100 trees in the random forest classifier, let's say the first tree is predicting no, the second tree also predicting no, so and so forth, and some trees predicting yes, some trees predicting yes. So assume that this is classification and you have two outputs: success, failure, or yes or no, kind of. Okay, so some no's you have got and some yeses you have got. So you will take a count of how many no's you have got, and you will find the counts of how many yeses you have got. Whoever is a majority wins. So let's say there is a bank note problem. So you got, this note is not a fake bank note. I repeat, this is not a fake bank note. You got 57 votes for no, and you got 43 votes for yes. Who is majority? 57. That's it. That's going to get reported to. So you will declare this bank note is not fake, because majority tree says is not fake. So how simple, right? In case of regression, you go for average. In case of classification, you go for majority. Simple. Okay. Now, I have some impromptu questions. I'm not deleting what is on the board. Let it be on the board. I have some impromptu questions. Listen to me very carefully and please answer. My first question: can some records be left out from every bootstrap dataset? Yes or no? Okay. How do we find what percentage of records have been left out of the bootstrap dataset? What is a term which helps me finding it? No, 3 is not a term. Term, I said term. What is a term which helps me to report how many percentage of records were left out? Good picture. It is out of bag error, not out of bag. Out of bag is a quantity of records left. Out of bag error is the percentage quantity reported. Correct. My next question. In the case of random forest regressor, in the case of random forest regressor, how do you report the final answer? By taking the mean or the median? Correct. Mean, that is average of all. Very good. In the case of random forest classifier, how do you report the answer? Is it the majority class or the minority class? Correct. It's the majority class. Perfect. Correct. You can say mod also. That is also right, because mod also means higher frequency. Correct. So consequently, I'm very happy that all my participant friends are very clear on this. Any questions? Anything which you have learned somewhere else, and you think that you are able to correlate with this but getting confused, please, I'm holding for 1 minute, ask your questions. Post your questions on the chat, I'll answer. Okay, seems no questions, so people are all clear. Very nice. There's some question come up now. It was discussed yesterday and 100% same as you explained, so no doubts. Okay, cool. Okay, I've kept some theory part, for the completion of the notebook. So what is the advantage, what are the disadvantages, kind of, because we always wish to compare things कि अगर हम कोई चीज़ अभी पढ़ रहे हैं, if you're learning something, then how is it good or bad then compared to others. Okay, so friends, now without wasting even a single minute, this is a big notebook. We have only 1 hour in our hand to complete it. So please be fast now. Random forest regression, you already have the data set of the US states. And please notice, right now, it is very fresh in our mind. All of us have got dissatisfactory results from the decision tree regression. When I used decision tree regressor, decision tree, not random, decision tree regressor, when we used just now, we got the RMSE value as 77.75. At least I got this value. And my average was 57.6. My God. So that means decision tree regressor is out of picture. Let us take help from random forest regressor. Let us see, is he able to improve things? Let us see. So without I prompting anything to you, tell me when your read CSV is done and head is, and you have printed the first 5 records in your collab notebook. Come on, tell me yes quickly. Okay, good. I don't think so you have to do any mehnat here now. Maybe the code is missing from a notebook, but all of us are smart enough. We know the data set is same. So we can go to our previous notebook. Which one? The 7th one. Sorry, not 7th. The decision card, the previous notebook. And we can actually pick things, no? At least what things are going to be common. The X and Y is going to be common. The splitting of the data is going to be common. What is not going to be common? Now listen that. Obviously, you will not import decision tree regressor. No? We are learning random forest regressor. So we have to import random forest regressor. So from sklearn.in symbol, why in symbol? In symbol means collection. So symbol import random forest regressor. I have made an object of the regressor and I have given number of estimates, number of trees you want as 20. Random state has been given so that all of us get similar answers, so that it is worth that we can talk to each other. Regressor.fit is fitting the itself to the data. So all 20 trees are going to get fit to the, remember 20 trees are not going to get the entire data. No. Each tree will get a small percentage of the entire data. What percentage we don't know. That is decided by the random forest regressor itself. We don't decide that. Okay. So small part of this bootstrap data set would be created. 20 bootstrap data sets will be created and will be given to each of the estimators. And then finally, the regressor is made with 20 decision trees. Now it is predicting on X test to get the Y prediction. Okay, right. So after this, also, I think this part of the code should be there in your notebook. Is from sklearn import the metrics and I'm printing the RMSE value. Okay, let me run it right now and see. Do I get a better answer? I got a better answer. 64.93 is what answer I've got right now. Okay. So how many people have ran this entire code, and if something was blank, they have filled up themselves and got the output. And if they have got the output, what is the RMSE value? Please punch on the group. If somebody's got stuck, please don't hesitate to ask. We all are a big family learning here. We all are friends. So don't hesitate to ask. Yeah, go ahead.
Training and making predictions code.
Okay. Okay.
Because we have imported random forest regressor here. That code is missing in the program.
Okay. Vaishali got 64.93. Same as I have also got the same. Huh. Jayashri, the notebook numbers with me and in you would be different, so don't worry about it. Look at the content, Jayashri. This notebook number is the same notebook is there as AICT 5 for you. Okay, Indrajit also got the same on 64.93. Okay. Dr. Kranti 65.58. Okay. Okay, I'll tell you one thing. Did the random forest regressor give a better result as compared to decision tree regressor? Can you do little mehnat for me, all of you? Can you report to me both the values? Like for example, for DTR, you should write like this. DTR, I got 77.75, and regression, regression tree, or regression forest, random forest regressor, I got 64.8. So I see a clear cut improvement. Can you put that values for me so that we will come to know is there any improvement or not? Fantastic. So in Apeksha's case, Dr. Pushpa, fantastic improvement. Indrajit, fantastic improvement. Wow. Manoj, fantastic improvement. Bismita, I have to put for DTR and RFR separately so that I come to know what kind of improvement you have got. Okay. I can see for all of us, it's a majority thing. All of us can see an improvement when we went from decision tree to a random forest. It's a clear cut improvement. It's not a case of improvement is only in one case or is coming for one particular faculty, other faculty is not getting the improvement. Data remaining the same, algo getting changed. I see a clear cut improvement. Okay. Now, because all of now have been able to compare two algorithms, I don't want to trouble you right now because I'm going to waste of time. Let me be very honest. I took the same data. I repeat, I took the same data of random forest regressor, which I've taken right now. In the case of the linear regression notebook also. So I hope you remember that time. So if you compare with linear regression, don't do it right now. Maybe later on when you get time, you can open that notebook also and check that what RMSE value you got there. And then you will come to the out of the three algos, RMSE is best where? Linear regression, that is multivariable linear regression, or DTR, or RFR. So among DTR and RFR is one. Now we want to see among RFR and multivariable linear regression who is winning. You get me? You like to take the challenge right now? You'll report to me. Come on, do it. Multivariable linear regression versus random forest regression. Who is winning? Come on. Who wins? Tell me please. Open your previous notebook and find out and tell me. I'm sure उसमें वहाँ answer रहेगा. You haven't run anything. The answer would be there. Like IPL matches going on. No? It's instead of the IPL teams uh, of RCB versus MI or RCB versus Rajasthan Royals, you are having your machine learning algos competing with each other. As simple as that. You can answer at least one. Multivariable linear regression versus RFR. Who wins? What is the RMSE value for each of them? Okay, Vikas has been the first to answer. Vikas says MBLR, in my case also 68.51. I remember this value, fantastic Vikas. And RFR, even I have got 64.93. We're getting the same answer. So Vikas, who wins out of three algos? Come on, who wins? Absolutely. RFR is a winner. So among three algorithms, RFR is a winner. As of right now, we don't know what we're going to do on Monday. We don't know what other faculties are going to do on other days. And once you learn more and more algorithms, as you go on applying, you will clearly see that out of all the many algorithms, one person will definitely be the clear winner. Not for, only for one, for all. All of us will find him the winner. Okay. And remember this question: if you ever meet somebody who's a developer and you ask him, "Okay, which is the best algorithm?" There is no answer. No book can ever answer this question, written by the best of the authors who have spent more than 15-20 years in development and maybe 15-20 years in their machine learning AI career. Even they can't answer this. Whatever is the best algo you pick up, you have to try it out by programmatically the way we are doing it right now. It is only after trying. It's very simple. If you go and ask somebody which is the best car to buy, what is the answer? How can you answer which is the best car to buy? You drive it, right? You drive it. So it totally depends upon the driver of what car he finds the best. You know, somebody may find a Volkswagen the best. Somebody may find an Audi Q3 best. So it's on you what you drive and what you feel comfortable. According to you, you say that is the best. But something, if you say A is the best, that may not be for others, right? That means, so that as the driver changes for the car, data set changes. As the data set changes, the algorithm's bestness of performance will also change. Okay. Yeah. Yes, you can definitely find the set of algorithms which could go with some data. If you recall your FDP1, I mentioned this very clearly 2-3 times in FDP1, that always do EDA. And when you do EDA, we do plotting by using Matplotlib and Seaborn. So we do a lot of plots. If you remember, we did a pair plotting where we plotted every feature with respect to every other feature. That helps us to analyze: is my data showing any kind of clear-cut classification, or is my data showing clear-cut any kind of linear relationship? So if it's showing a linear relationship, please dump your data to a LR. You're born to do good, 100%. But if your data doesn't shows that kind of tendency of any kind of linear relationship, दूर दूर तक कोई linear relationship आपको दिखता नहीं है आपके data में, then please don't try single variable SVLR or multivariable MVLR. Don't waste your time. Straight start from DTR or RFR and then go up from it. Okay. Right. So more you practice, the more you get an hang of it. Saying and speaking will be of no sense because it differs from data to data, context to context. Okay. Now let's see what I'm doing next. If the number of estimators which is changed to 200, the results are as follows. Kind of a regressor. I'm making the number of estimators as 200. Instead of 20, I'm making it 200. All the steps are same. Please notice there is no difference. All are same. And now I have got my RMSE even better. My RMSE is even better. From 64.93, I have come down to 59.14. Oh, that is making sense. That means if I'm increasing my number of trees, I'm getting a better RMSE, and I have come to very close. I know I'm still above. I know that. Vaishali, even I know that we are still above 57.6, that is what it is. We can't defy reality. This is reality that हमको हमारा performance up to the mark नहीं मिल रहा है. Okay, but yes. So what we're going to do? We're going to do tuning. So little tuning we did is by increasing the number of estimators, and we got little better results. Okay, but still not satisfactory. We got better results, but we are not happy with the results as of right now. Okay, so how many people have got this answer? 59.14. Please punch on the group. Okay, so many people are saying got it. Very nice. The learners have to all try later on, post 7:15 when the session ends. So whenever you get time, try for 220 and 250 also. Not now, please. Try for 220, 250 later on. If anybody who is from computer background and is able to match up with my speed, and he feels that Arey yaar, I can go faster than how Rocky sir is explaining, that's okay. Then in that case, please multiplex and do for 220 and 250 and punch the answer on the group. If you have a computer background and you can do multiplexing, you can listen to me as well as you can do that, then please do it. Okay, now we are moving into RFC, random forest classification. If you're a non-computer person, then please pay attention here. Don't run behind multiplexing. Friends, we're taking the same data set of banknotes, which I think we already have. We have a data set called bill authentication.csv. We already have a data set called bill authentication.csv. So there's only download the data because you already have it now. So what we're going to do here is, this data called bill authentication is having details of rupees 2000 banknotes, 2000 rupees banknotes. You are well aware that RBI has banned at the beginning of this year, Jan 2020, no more printing of 2000 rupees notes is being done, because a lot of terrorist activities were found being funded because of that, because they were printing duplicate notes. So how do you distinguish a note to be duplicate or a real? So when you take a note, actually, if you go into a bank, you will notice they have a small kind of machine which scans your rupees 500 notes, and they say ये note fake है, ये आप देखो ये असली note नहीं है. That way. So the point that I'm trying to bring about to you is that particular bank note, how did it actually identify? Basically, every image which you actually click off a note has some image based properties. So the image based properties like wavelength, transformed image, skewness, entropy, and kurtosis. You'll be wondering that how do these parameters? So let's not bother about image ke parameters ka kya relevance. Let's not bother about it, because that's not our focus right now. Point is this, that if I click a photo on my phone, let's say if I click a pic of a group on your phone, and nowadays your cell phones have a lot of filters. So you do the filtering, you make it grayscale, or you make it look ambient, or you make it look sunny, you make it look warm. What are you doing actually? You're playing with the different parameters of the image. So these are some like parameters like that, simple as that. Okay. Now, so bill authentication.csv, you have loaded the data. I have checked the shape and the head. I'm giving you only 1 minute to load this bill authentication.csv into your Colab and run this piece of code. Read CSV, shape, and head. Okay, so Dr. Kranti did multiplexing and has got the answer as 220 59 and 250 59.2. Okay. Matlab, Dr. Kranti, we didn't see much of an improvement even after increasing. the value to 220 and 250, we didn't see much of an improvement, which is not a good story. We're still above 57.6, which is a threshold for us. Okay, Apeksha says done with loading and reading heads in dataset. Very good. So like Apeksha, how many people have done loading of data? Say loading, yes. Dr. Pushpa, how come you have become super fast today? You're going like me. Hmm? Good, good, good. Hmm. Now, majority people have said yes, that they have loaded the data. Okay, I'm still waiting for a few more yeses, please. Few more confirmations. Hmm. Okay. Now, as majority people have said that they have loaded the data and have done the head command. Please remember, every notebook of mine, I've sanitized it because any human who wants to learn things, when you see a standardized structure repeating for 3, 4, 5, 6 times, you are confirmed this is the way the problem has to be solved. This is called as an ML pipeline. We are all happy and safe as of right now because there is no data cleaning that is required. That's okay. If data is clean, therefore data cleaning is not required. But anything which is getting added up in this pipeline is going to be only data cleaning. That's it. Rest of the steps have to remain the same. So first step, you will divide the data into X and Y. Next, you will split the data. And today is a Friday, right? Today is a Friday. That's right. So tomorrow, I believe your topic is PCA. PCA stands for Principal Component Analysis. And there you're going to learn something called as feature extraction. Because when there are too many columns, imagine when there are too many columns and you don't want to use all the columns in X, then you can avoid a few columns and choose the best ones. So that's the reason we do something called as dimensionality reduction. And that dimensionality reduction is done. There are many algos. One of the best and most used algos is PCA. Okay, so that is also one additional step which gets added up to the pipeline. So that is a part of data preparation. Okay, right. So once data is completely prepared and neat and clean, then only I will do my preparing of getting my X and getting my Y. So what I'm trying to tell you again and again is this pipeline steps don't change. You may add something before it, you may add something after it, but in between nothing is going to come. In between the steps are going to remain the same. Okay. Vandana, sir, is this kurtosis same as kurtosis? No, 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 no. That kurtosis and skewness is the different. Kurtosis is the measure of the tendency of skewness in your statistical normal distribution, and this is different. This is different, little different here. One of the qualities of the image actually. Okay, the next is splitting the data into train and test split. Then I am loading from sklearn.ensemble import random forest classifier. So can you please tell me what code is missing from your side? Come on, tell me what code is missing from your side. This code only. Okay, so the code in which I am, it seems that is missing. So from sklearn.ensemble import random forest classifier, I made an object of classifier. I specified 20 trees. 20 estimators means 20 trees. Then I'm doing the work of fit and the work of predict. Okay, I'm punching that entire code to you, friends. Hmm. I believe that the code for sklearn.metrics is already there with you. I believe that. Okay. Basmin is the first person to report that she's got accuracy of 98% and S. Devi's got 99%. Indrajit, that's the right figure. 98.54 is the right figure. Yeah, but so between 98 and 99 classification accuracy mostly सबको आएगा. Right. Very good. Okay. Now, how do I read my data? Okay, I've got my output of confusion matrix, which says that there are 155 plus 2, which means support. Look at the support, 157. So there are 157 bank notes in the category 0. There are 157 bank notes in the category 0. Okay, so that means there are 157 not fake bank notes. Out of that, your algorithm was able to find 155 correctly and 2 it misclassified. Look at the next row. Remember, always go diagonally. You have 2 classes, you will have 2 rows. If you have 3 classes, you're going to have 3 rows. If you have 10 classes, you're going to have 10 rows. You should only look at diagonal elements. Okay. So the diagonal elements here says that there are 1 plus 117, 118. So in your test data set, there were 118 bank notes which belong to the category 1. There are 118 bank notes which belong to category 1. Now, category 1 here means the fake bank notes. Out of those 118, your algo was or your model was able to classify correctly 117. It misclassified 1. So total misclassifications 1 plus 2 is 3. And 3 upon 275 is 98.9% as in my case. So 98.9% is a fantastic, is a beautiful accuracy of classifier. Okay, now the participant can do one thing. You can just try 10 and 50 quickly right now. Just put the number of estimators as 10 and punch your answer on the group. For 10, punch your answer on the group, and for 50 also punch your answer on the group. But punch it together. 10 का भी और 50 का भी साथ में punch करना. That's okay, Abhiksha. That's okay. 99.36. You will get an answer about 98. That is important. 98 के नीचे जाएगा तो गड़बड़ है. With 30, I got 98.9. Okay. 10 is 98.09. Okay. Vandana, the bootstrap data set is different. No, the bootstrapping part is not fixed by us. The data set is fixed by us, but bootstrapping part, though, it is on the random forest. Therefore, the answers will differ slightly for all of us. Okay, Apeksha says 10 का 98.55 और 50 का 98.99. Okay. Okay. So I really don't see much of an improvement. Like nobody's got 100, no? Has anybody got 100% classification? Or like 99.5 के ऊपर आया किसी को? I got, somebody says I got. Dr. Kranti got 100%. I don't believe it. For 50? 100%. Are you sure? Dr. Kranti, run your code once again. Just run your code once again. Then tell me the answer. Manoj has got 98.9 for both the cases. 10 as well as 50. Cool.
So, sorry to
Yes.
interrupt you. This is
No
Apeksha.
problem. Mhm.
I just wanted to know if I run it with the same estimator, if I run the code again, will the answer change?
It
Because
will. Yes,
just now I have
It can.
for 50,
Mhm.
it did change.
It can. No, it can change because of the fact that every time when you run it, the random forest regress classifier object is being remade. No, you are making this object newly every time. No,
Yes,
you are
yes.
making. So
So
every
the
time you
new
make a
set
new
of
object,
data is
trees,
taken.
trees,
So
trees.
it
New set
changes.
of trees are
Okay.
being created.
Okay. Thank you, sir.
Okay. So, Dr. Kranti, this is very rare of a case. Actually, you've got idealistic classification. So, unfortunately, the sorry state is that your RFC has got overfit to data. Clear-cut case of overfitting to the data. You know what you can do, Dr. Kranti? To check whether your data is got overfit or not, do one thing. Change the test size to 25 or make it 30. Just change the test size to zero point 0.3 and try Dr. Kranti right now and give me the answer. Hmm. Yeah, that's okay. So, Varsha, for 50 after running twice, it gives 100. That is okay. But the point is that getting an answer is 100 and running it recursively is giving you 100 because your RFC has got overfit to your model has got overfit to the data. So, to check it, what you can do is just change the test size. Make it test size as either zero point 0.1 or zero point 0.3. Do it and see.
Now it is 0.99.
Correct. Correct. So that means it's the previous case the model got overfit to the data. Overfitting,
Yes.
yeah, overfitting means overlearning. So
Yeah.
in simple हिंदी भाषा में से वो रट्टा मार के गया है, एकदम रट चुका है डेटा को वो. Okay, right. So now I believe all of you are more comfortable, uh, more confident with all this machine learning which is happening, and you're now more happy to see that you learn some heavy concepts of theory in the morning times. Maybe many concepts. I can't speak them out because it will not make sense because you have already heard them. So you have learned so many new concepts, and now you're realizing that okay, how are they fitting? You know, you are able to see from code how they are fitting in place. Okay, if I really get something which is overfit, how do I come to know overfit hua? So Dr. Kranti was a case which I knew. It's not in this particular session. Every session I would be taking, I'm bound to see out of let's say 30 40 participants, two participants getting an overfit case, two participants getting an underfit case. These cases are always going to be there. And when that cases happen, that's the reason I told you we are all learning as a big family. We are all learning as a big team. Because if I just keep executing my own notebooks, I won't learn much. But when I look at the comments of other people, okay, some what people have got as an answer, and then I impromptu answer, abhi aap ye karke dekho. Now you do that, you do this. That's the way we learn more. That's called as peer learning. So we all are peers. I'm not a teacher in that case. We are all peers to learn from each other. Okay, right. So let's now go to the next step. Now, big question to be answered by all of you. Very big question. How do I get the best value of the estimators? Because it is so confusing. You gave 10, you got some answer. You gave 50, you got some answer. For 20, you got some answer. Now you do not know. If I keep as 100, will the answer improve or go worse? I don't know. Let us check. Let us check. Because let me read the question first. Remember, it's not always best to have higher number of estimators because higher number of estimators means more decision trees naturally, which means more time to give an output naturally. So what should I do? It's a very simple funda. You know, let's not let's not hype up machine learning is difficult. No, it's not. So because I did my base graduation in instrumentation engineering, so I really believe, and I was very good in control systems. Like I was too good in my subject of control systems, and I used to love that subject. I was the only person in my class who actually bought this book called Liptak. It was costing 8,000 rupees way back in 98-99. So you can imagine. So you know that book Liptak, वो उसको पढ़ना ही मुश्किल था, उसको पूरा पढ़ना ही possible नहीं था. But the whole third year and the whole fourth year, that book of control systems Liptak, which is about 2,000 pages odd book, hard copy book, uh, was a reference point, and that was far more difficult in terms of its maths and control systems, the way what we do in machine learning now. But I can correlate very clearly with a 20 years of experience. I'm able to correlate everything very crystal clear, that whatever we are happening in doing control systems, we have nothing but converted all that into machine learning. It's nothing different. If I'm sure if some of you are from control systems or you have dealt with that subject, you person agree with me. Terms are getting changed, that's okay. That's fine. But effectively the logical part remains the same. So let's now move with this. So follow hints to answer the question. So all of you are going to go into a test now. Loop through values 10 to 200 step by 10. Loop through values 10 to 200 step by 10. Okay. So want the number of estimators to range from 10 value, and so the range, if I'm sure everybody knows the range function says start value, end value, stepping value. I repeat, start, end, stepping. So you start with 10 and you jump up by 10 by each time. So 10, then 20, then 30, then so on and so forth. You're going to go up till 201. So whatever value you give here, it will go one less than that. It won't go up till that. So it is going to go up till 200. Okay, but if I keep 200 here, no, then it will not pick up 200, because by rule it will go up till 199. So I've kept 201. Okay, let's see now what I'm coding and how I'm coding. There is only one tricky part here. The rest all of us will understand very well. There's one tricky part, so get the hang of it. I have made an empty list called error. It's an empty list. In this list, as I run my loop, I would one by one, in every iteration, in every loop, I'll go on appending whatever error value I get. So let me pick up this part of the code. Let me put it on a complete white screen where it is very clearly being understood in bigger font size. And in parallel to it, we also have our whiteboard to do some diagrammatic representations if required. Okay, now I'm not looking at the chats. For some time, don't put anything on the chats. I can't look at it. It's hidden. No? So first thing first. No, let me rearrange my screen. Just a second. Let me rearrange it side by side. That would make more sense. Okay. So friends, my for loop is going to run for 20 times 10, 20, 30. It will go up till 200. So in stepping of 10, this guy is going to run for 20 times. First time, value of I will be 10. So what we are doing? We are making an object of random forest classifier. The first parameter is number of estimators is equal to I. But you and I both know I is 10. In the first instant, I is 10 in the first loop. So we have formed basically an RFC, random forest classifier, with 10 decision trees. Okay. Next, telling him to fit, telling him to predict traditional steps. So look at the tricky part here. What is this all about? Okay. Now, friends, what happens is when you are going to compare, predict underscore I is actually having the predictions which have been made from X test. Okay. So let's assume that X test, I think X test is about 20%. No, we have kept test sizes 20%. I don't know how many total records are there, but anyway, let's ignore it. Let's assume that we have total of 100 total records. Then obviously X test is going to have 20 records. Okay, so there are obviously going to be 20 outputs in prediction. For 20 inputs, there are going to be 20 outputs in prediction. Now, what do you expect of a classifier to give you an output? क्या आपको classifier output दे सकता है? Classifier can only give you an output like a 0 or a 1. Isn't it or not? That is it belonging to class 0 or class 1? Because the problem which has been has only two classes. Either the bank note is fake or it is not fake. There can't be a third category, no? So I'm going to get my prediction a numpy array. I repeat, a numpy array with the numbers given to the class either as a 0 or a 1. Okay, fine. Now, if you recall our FDP1 session where we did with practicals of numpy, so we understood the beauty of numpy is that numpy arrays can participate in every mathematical expression as if two numbers can participate. Like for example, you can add two arrays, you can compare two arrays like this, not equal to. Wow. So what is going to happen? This is going to happen. When you say that, just a second, let me delete what is not required. Give me a second. Right, so what we have is prediction of I. Now, Y test is having the original data. Suppose the original data is like this. Suppose if I put first two values as 0 and then intermediate I forgot and the last value I've kept as 1. Suppose the value is like this, 0, 1, forget the intermediate part and the last value is 0. So when you do not equal to or equal to, whatever comparison you do, the values are going to be compared one by one. So the 0th position value of predict will be compared with the 0th position value of Y test. So when you compare these two, 0 with 0, are they equal? Of course, yes, they are. So somebody is asking you predict of I value, first value, which is 0, is not equal to the Y test value. You say, no, it is equal. How can you say not equal? It is equal. 0 is equal to 0. Correct. That means when somebody says not equal to, your response is going to be false. No. Barabar hai. That's correct. Because these two are equal. And somebody is asking you, are they not equal? You will say, no, they are equal. So no means false. So your reply is going to be either no or false. Okay. What is next step? Next step is that this is 0, this is 1. 0 not equal to 1. Huh, that's right. 0 is not equal to 1. So you will say yes. I will hear the yes is true. Correct. So yes or true is going to be the output of this. Correct. So in short, your entire result is going to be a collection of either true or false. हाँ, ये बात तो सही है. This is correct. My entire output is going to be collection of true or false. Now what we are doing is we are smartly finding the mean average. How can you find average of true and false? Patience, we can. So you're finding the mean or the average of these values. Because every true here is attributed as 1 and every false here is attributed as 0, therefore I can see very clearly some values like zeros and ones. Now you imagine, what is troublemaking for you? Troublemaking is when you say that the prediction of I was not equal to Y test. This is troublemaking, no, for you. You will say, how this troublemaking? This is no. See, when the prediction is not equal to the actual value, that is what is your concern. When it is equal, you're not bothered about it. So that means you are bothered for the true values, correct? Because if you got true, that means your prediction did not match with your test. That's right. And true are nothing but ones, correct? So if you have a 1 and 0 combination, I think if we use the mean function, you've got the output, because let's say mean is 1 plus 0, 0, 0, 0, so all zeros, and then again some ones are coming. So if there are very few ones, imagine if there are very few trues, there will be very few ones. Barabar. If there are very few ones, that means your answer is going to be close to 0, like 0.1, average will be 0.1 or 0.2. That's right. So getting a low value of mean, the lower the value of mean you get, that means lower is the error. And because this error is not in any sense, this error is not in any sense a mean squared error, but this is an absolute sense. You're comparing two things, so we can say that this is not mean, but this is an absolute. So this is an absolute error because we're taking an average of it, so we can say mean absolute. जितना जितना इसका वैल्यू कम होगा उतना obviously वो better होगा. I hope you agree with it, right? So this is what I'm doing. So for every iteration, I'm finding the error value and I'm appending it to my list. Okay, right? So is till this point understood or not? If till this point is understood, please punch me a yes on the chat. Very nice. Now, how many of you don't have this code? That means, I don't know, is this code of the for loop there or not there in your notebook? It's not there. Okay. Code has come. Please be very careful. You may get indentation errors. Please be very careful. See on the screen, watch carefully, and then do it. Okay. So Vismita says she is done on this. Very good. Vikas done. Indrajit done. But I'm still waiting for a few more acknowledgements. Okay, we have to say numpy as np. Yes, I think we have already said that. Basmita, I think we have already, in my notebook, I have already imported numpy as np before. So if you just check your notebook, you will see numpy as np imported beforehand. Right. Dr. Kranti is mentioning error equal to empty list. Yeah, but I believe all of you can type this, instead of punching on the screen. Please be careful, everyone. Before the for loop, there is a error equal to empty list. If it is not there, please type it. Okay. So I hope all of you are all set and you're ready up till this point. Now the next. See, we have realized now that if I run my for loop above, I would get all the errors in the error list. But keeping them in the error list will be of no use. No, I have to maybe print it or maybe plot it. Plotting would be more clearer. So we are plotting it. So let's see what we are done. In matplotlib, we import matplotlib .py plot library as plt, which I have imported in front of you. I made a figure object of given some particular size, and we are plotting. So when you do normal plotting, it's going to do a scatter plot. So we have done a normal plot here mentioning range 10, 201, 10. Why this range? Because plot functions first parameter is x value, and the y parameter is the error value. So the x-axis value is the range 10, 20, 30, 40, and the y value is the error. I want red color dashed lines to come, which you can see on my screen. They are coming. Marker to be 0 indicates this O over here for marker symbol is a symbol for marker. If you refer our matplotlib notebook once again of FDP1, you will realize that markers can have a lot of different shapes. Marker face color to be blue, so they are all filled with blue color, and the marker size is 10 pixels, so they are quite, they don't look like a dot, they look like circles. They're quite big in size. Okay, X text means at what points do you plan to put the text? You see this text here, small text here, and 10 written below. So at what points do you plan to put the text? You can change that by changing X text, but preferably put the X text for whatever X values you plot. Title X label, Y label, self-explanatory. Okay, so is this code, once again, same question. Is this code there? Or okay, Vaishali's answered. Code for plotting is not there. Okay. Be very careful. As you can see on my screen, actually speaking, this plot functions, line style, marker is all in one single line. Don't be under the impression that they are like I pressed enters and bottom the next line. No, it is because of space management, this guy is taken it to the next line. After you get the plots, I repeat, after you get the plots, like Dr. Pushpa says she's done with it. So after you get the plot, please tell me for what range of number of estimators you are getting the least error. For what range of estimators you are getting the least error. Okay, Indrajit is the first to answer. He's getting the least error for number of trees from 120 to 200. Okay, very good. Dr. Pushpa says 20 to 50. Very good. Apeksha, oh, such a wide range. Apeksha says from 100 to 200, she's getting the least error. Okay. Mhm. Indrajit and Apeksha, both of you, can you please tell me what has been your state for splitting the data? Can you please tell me what have you chosen as a random state? Like I have selected random state as 10. What about you? 10. I have a next step to tell you all. क्या करना है? But before I tell you what is the next step to do, that's okay, Apeksha. Obviously, if your values are different, the graph will be different. Obviously, no? Like you're going to have a kind of a V shape coming from 100 to 200. फिर वो ऊपर रहेगा. It will be above and then coming down from. Hmm. I'm
Sir,
getting
in my case, I am getting this error to be constant in all the cases, and that is 0.003636.
okay. So are you trying to say that you're getting a constant straight line?
Yeah.
Okay. Let me help you with that. Wait,
Z-type
wait.
curve it is showing, sir. Z-type.
That's okay. That's okay. That's okay. You may get a V-shaped curve, Z-shaped curve. That's all okay. All acceptable. It is acceptable. What kind of curve you're getting is acceptable. Question is that whatever curve you have got, uh, can you tell me for what values you are getting the minimum error? Okay. Now
Okay,
somebody came
10
on
to
audio.
100.
No, don't tell me on audio. Put it on the chat now. Now somebody on the audio told me that he is getting a fixed straight line. A fixed straight line. Who was that particular person? Please at least either come on audio or come on the chat and say your name.
Sir, me, Vikas.
Vikas. Okay. Because the mistake which you would have made is this. Try and have a look at here. Your number of estimators equal to I hai na? Just check. I think this
Uh,
value of I would have become a fixed for you.
no, sir,
It
it
should have
is
been I.
I. It is
No, no,
I.
no. No, I'll tell you what mistake is happening. The random forest classifier which you're using here, uh, it is unfortunately getting mixed with the classifier which you made above. Just try to change the name just to classifier 1 and classifier 1. Just change the word classifier to classifier 1 and try once again.
Okay.
Mhm. Dr. Kranti says 20 to 30. Okay.
No, I am still getting the straight line.
Um, Random state is there, no?
Yes, it is equals to 10.
Change it to 0 and try your code once again. Yeah, Vaishali, you are following the instruction which I'm going to Vikas. Say follow the same instructions. Make the random set to 0 and try it once again.
Yeah. Now I got some
Shape,
different values of,
some
yeah.
shape, some shape. That's it. That's it. Okay. Okay. Now all of us are going to go in a very critical part. Hmm? Okay. Apeksha says you're getting the least error for 10, 40, 70 to 80, 100 to 200. Good, no? Vaishali says now a different shape. Okay, cool. Now listen to me very carefully. See, now there is some part which you need to do yourself. But I need not come and tell you anything. I need not type anything. I should hear from you. All of you have got some best number of estimator. That means you've got some best value of n, which is giving you the minimum value of the mean absolute error. That is the mean y-axis value. Hmm? So you're getting the min value of the mean absolute error. Friends, I think somebody's audio is on by mistake. Please turn it off. So I repeat, you're getting the best value of n for some min. I'll take one particular case. Let's say the case of Varsha, I can see in the chat, Varsha has written in the chat that she's got 20 to 60 as her n value giving minimum error. Now it is very obvious, no friends? If somebody tells you कि 20 to 60 number of estimators हमको आ रहा है, तो we are not fools to choose 60. Why will you do that? I will choose 20 because smaller the tree, the faster it gives me an output. And moreover, you know very well that even if I increase the number of estimators, I'm not going to get a better efficient, I'm not going to get a better accuracy because my error remains the same. So all of us are now going to look at this brain work which we're going to do with patience. You shouldn't miss out on things. You now have the same random forest classifier. Go in the above cell in the random forest classifier and try with the value of 20. This is the case of Varsha, 20. Okay, but if it is the case, let's say of Apeksha, not Varsha, it is a case of, let's say, Apeksha, whose output are also visible in the chat to everyone, is Apeksha's case. Okay, Apeksha's case says she's getting a minimum error at 10, 40, 70 to 80, and 100 to 200. So it's very natural that in her case, I will choose the value of n as 10. All our answers are going to vary a little bit here and there, because after all, random forest is going to make its own decision trees, and each time is going to use its own bootstrap dataset. A bootstrap dataset kya ja raha hai, that none of us are controlling. No, total dataset is same, I agree, but the random selection with the bootstrap dataset does over the entire set, that is random now. So little variation in the RMSE value will come. So what I want is this. I want you to find RFC for 20 in case of Varsha, RFC for 10 number of estimators in case of Apeksha, and let's say in case of somebody else, I remember somebody else said I'm getting best value from 100 to 200. So in that case, for that person ABC, your n value is going to be 100. Okay, so I want all of you to report to me in the next 2 minutes. For what n best value have you got what accuracy for RFC? Please make your answer look like this. Your answer should look like this. N equal to, let's say, 100 in case of that person ABC, comma, accuracy ACC equal to so and so, whatever you got. Question mark. Okay. Yes. Come on. Please punch in your answers. Apart from your answers, if you have any design related, any concept related queries, you're welcome to ask, because some people will take more time to punch their answer, no? So you're getting a 2-3 minutes ka span. You can always talk to me and ask your questions. Vaishali, accuracy cannot be 0.036. That is an error, Vaishali. That error is 0.036.
अच्छा सर, रॉकी सर, अभी
yes.
ये n इक्वल टू 100 और 120 वो कहाँ डालना सर? रेंज में डालना ना?
No. You have to go to the above code and put it above code.
मैंने कहा वही ना.
Don't disturb this code at all. Don't disturb this code
अच्छा
at all.
अच्छा, वहाँ ऊपर, अच्छा ऊपर, ओके ओके. एस्टिमेटर्स की जगह, ओके ओके.
Correct. Previous code shell में जाके करना है. हाँ. Okay. So Indrajit has reported his answer very correctly. Dr. Kranti has reported his answer very correctly. So please report your answer the way Indrajit or Kranti has reported, and that will make sense to all of us. Okay. If somebody's audio is on, Dr. Pushpa, your audio is on.
हाँ, ओके ओके, वेट.
Okay, as Buma Devi's output has come, all outputs are as expected. But still, this is about 6 outputs. What about others? Okay, for 100 is 98.9. Okay. So Masmita and Dr. Pushpa's is 100. Okay. So some lot of people, what I can notice is that I think that the whole batch is getting divided into 2 classes or 2 clusters. There's a clear-cut clustering here. One cluster of people got their best answers in the range of 20 to 50. and second cluster, the people got their best answer from 100 or maybe 120 to 200. Try to notice this. Try to notice this. So all majority people are getting into any of these two clusters, either 20 to 50, or maybe you got 10 to 50, that's okay. But then again, so any value from 10 to 50 you choose, you're getting good accuracy, and 120 to 200 also you're getting good accuracy. That means on this nature of data, we can generalize that at any point of time, we are either going to use a number of estimators in the range of 20 to 50, or we are going to use the estimators in the range of 120 to 200 on this nature of data. Okay, right? It's, remember, if you change your data, your number of estimators will also change. Your graph will change. It will look different. Okay, so that's very important for all of us to understand. But this is going to be the likelihood. So tomorrow, if some, so let's say you have been doing machine learning for, let's say, 3, 4, 5, 6, 7 months, like I've been doing for the last 3 years, continuously every day in and out. So if you have been doing for the last 3 or 6 months, you will not take time. I repeat, you will not take time. It will take you 5 minutes to judge that has the person what is talking, what is giving you is a genuine or is scrap. Because if I know that I have worked on some data in the past, and I know with my that simple Python coding which you just now learned, of course, whatever code pipeline we are creating, I'm again and again repeating, we will have to add a part of data cleaning or data pre-processing before it, depending upon the nature of data. But then, these things are totally dependent upon data. You really cannot teach them. The point is that you can teach them some points. You can teach them functions of NumPy and Pandas. Okay, these functions are used for doing that. But then point at the end of the day is, key once uh, even if you know about data cleaning and data pre-processing, uh, you have learned it over one data set, let's say D1, and if the data set changes to D2, all these steps are going to change. So this is something which you really cannot put it as a part of it. It's there. You have to have this in the pipeline, but what code you're going to write for it will differ from data set to data set. So now, whatever we are doing the steps here, once I have done this, I understand that I'm getting my best estimators in one of these two clusters. So if somebody gets up and tomorrow and tells me that Rocky ji, I've got the answer and I've got the answer best for 70, I'll tell my friend, go and check 1 second. I don't think you should get 70, because I see no reason of getting 70, because one reason is to come here or one reason is to come here. So it's very less likelihood that if anybody says my decision tree is working best for 70 or 80 estimators for this data I'm talking about. Okay, so this is the way you judge and how you distinguish between an experienced person and an inexperienced person. Okay, an inexperienced person will get excited by looking at the graph. Oh wow, must graph I have, very nice. Experienced person will introspect. Okay, the way we are doing right now. Right. So, friends, I hope you have wonderfully completed this. Can you give me one line or one word feedback? How did you love it, or was it fruitful, not fruitful? That you could compare 3 different algos and find the winner because of hyperparameter optimization, HO. I hope you loved HO. Okay, great.
Sir,
Yes,
I
yes,
have a small doubt.
please.
Generally, when you told that, okay, there will be 2 classes of ranging
Two
and
cluster.
mostly 20 to 50. So again, if at all we run so many times, maybe I will also get from 100 to 120, 120 to 200 range. I got a
No.
range of 20 to 50, right? The
Uh,
least error. And
uh-huh.
some people got, because it is taking on a random basis the data you told. So here,
Mm-hmm.
suppose I run this program for 10 to 15 times, maybe
No,
for me
then
also.
no, it won't make a difference. It won't make a difference. In fact, getting a value 20 to 50 is better than getting 120, no? Lesser
No,
the
no,
trees
but
is better.
yeah, I'm just asking because I am continuously getting 20 to 50 only. then how come they are getting different ranges? So what?
Yeah, that's possible, no? Because our random state is deciding on what breakup of the bootstrap data set is going to happen. So, but whatever
Okay.
value you're getting, you will get it firm there only. It
Okay.
won't change.
So
Mhm.
okay. So we will not get it changed once we get it. Okay.
Yes, yes. Okay, right. So, friends, my this session is over, and according to the schedule, we all plan to meet back on 23rd, and I'll be meeting on 23rd with this topic called K-means clustering, where clustering is a unsupervised ML algo. Okay, so we ended on classification, and we're going to start with clustering. So that's the continuity which I have kept in my uh, teaching pattern. Okay, right. So it's over to Sony ma'am. It's over to you. From my end, I'm completed. Thank you.
Yeah, sir. Thank you. Thank you so much. Sir, as you said that during this session that these hands-on sessions are broken linked list. But I'm sure that this broken linked list, if joined together, they'll just form an unbroken one.
Yeah, absolutely. I did say that, because these are broken, they're like a zigzag puzzle,
Yeah,
So you're getting small blocks. So once you join all of them together, you're going to get a much bigger and a wider
yeah,
picture. Mhm.
yeah.
Yeah.
Actually, we are lucky to have you on this FDP. The way you
Oh,
take your sessions are really making impact on us, sir. Your clear and precise explanation, the pace with which you go, you give time to each of the participants to clear their doubts. It's really commendable, sir. I'm really lucky to have you in this FDP, and also I hope that all the participants have enjoyed doing hands-on on decision cart and random forest today. So thank you very much, sir. We are looking forward to meet you again on day 6, that is on 23rd,
that's right.
where we'll be covering K-means clustering.
Right.
Okay,
Thank
thank
you.
you so much, sir. Thank you.
Yeah. Thank you.
Thank you, Rocky sir. Thank you very much.
Thank you, Rasa sir. Thank you.
So I request all the participants to join tomorrow's session at 10 a.m. sharp. Thank you all.
Thank you, Rocky sir. Thank you very much.